Hi, we're getting close to Christmas and the winter festival season. I'm starting to get into the mood and thought I'd do a seasonal project for this episode. A robot Santa head with face detection. This project has become bigger than I expected in every way. Physically, it's quite a big head, and in terms of the commode expanding in different directions. The concepts, though, are all quite straightforward. I'm going to split my explanation of the robot Santa into a couple of videos. In this video, I'm going to largely talk about the mechanicals, electronics and design, then demonstrate the robot Santa head working. Next time, I'll do a deep dive into the software involved on the Raspberry Pi Pico in C++ and a Raspberry Pi in Python. Please do like the video and subscribe. I really appreciate it. The concept here is to revisit the pan and tilt face masks that I did in the Halloween and Bonfire Night special. Then I recognised people by using HC-SR04 ultrasound range sensors. I'm scrapping the range sensors and replacing it with a camera. So we'll actually do facial detection now and move round towards that detected face. That means that I'm going to upgrade our system to be a full ROS robot operating system model. And of course that means using Micro ROS. The code on the Pico is going to be of course in C++, but I'm going to actually do the facial recognition on a Raspberry Pi 4, and that's going to be running Python and using OpenCV to do the facial detection. And that will control the colour of the eyes on my Santa and where it's pointing in terms of pitch and yaw. This video is sponsored by PCB Way. Back when I was doing the Halloween special, I had a problem because I was getting lots of connection issues on my breadboard and with my wires going to all of my sensors and controls. To get around that, I've actually had a proper PCB built, and that was fabricated by my friends at PCB Way. So now I've got something that I can be assured that all my connections will be nice and tight and strong, and it sits nicely on top of a Raspberry Pi 4, which is even better. So go check out PCB Way for your PCB fabrication needs, or 3D printing, CNC, sheet metal fabrication or injection moulding. Like a lot of engineers, I've over-engineered my board here. So I've put a lot of capabilities on this board, of which I'm going to use just a fraction for this project. So of course we will want telemetry and debugging. So I want my single wire debug SWD port, and I will want UART. And I've got two places I can pull that off the board. I want to drive a RGB LEDs, so 4 LED lines that are going to be driven as PWM. They're going to actually be common anodes, and then I will want pan and tilt, so actually I need 2 servo PWM ports. I put 5 on this board. So the board, and let's have a look at the virtual design of the board from KiCad. So we've got our 5 PWM ports down the back here, and I've allowed them to take power either from the 5-volt line going into USB into the Pico, or to apply separate power if I chose to do so. I can't actually drive enough power to run 2 of my servos straight from a Raspberry Pi's USB. That didn't work very well, so I am actually running on a separate supply. But actually I'm running them at 5 volts rather than the 6 volts that they should be run at. But it works okay. The servo ports are basically just coming straight off of the GPIO pins for driving the PWM line of those, and then I've got a common set of power running through them. The RGB LEDs are coming from the ports up the top here, and that's got a common anode as the second port on pin down on that. So we've got red, common anode, green and blue. The RGB LEDs, I've got 2 of those. It looks rather complicated on my schematic. The reason for that is that the RGB LEDs aren't actually on the main board. They're actually on little boards up facing the eyes. So it's just the header pins are the only item that is actually going to be fabricated onto the PCB design. All of the LEDs, of course, have 100 ohm resistors on them to protect them and keep the current low. 100 ohms because I wanted the brightness not to be completely full brightness for these LEDs. I of course put a reset button. So reset is of course just pull the run pin to ground, and that's all that is. For UART purposes, I could either take that off of GPIO 0 and 1 up in the top left, or as I actually prefer to do, take it off GPIO 13 and 12 and 13, I think, from memory, down the bottom right. The reason I like taking it off down the bottom right is it's nice and close to the SWD port, which means my wiring looks a little bit neater and I haven't got cables in the way across my board, well, any more than necessary. Now, there is a design error in what I've just built, which is not great. If you notice here, the eyes and the servos have a rather big overlap in the slicers that they're using for PWM. Slicers are what the Pico uses in order to go between its clock waveform that it's producing for PWM. Now, the problem with overlapping on slicers like this is PWM configuration is done at slicer level, and therefore we're going to have an overlap. For my servos, I need to clock down the frequency of the PWM. I need to actually adjust the count in order that I can also then get a 20 millisecond pulse width to work with that. That means that we're no longer counting up to a 16-bit value. We're now only counting up to 20,000, and that sort of affects my eyes approach and how I was using that. This is not ideal. This is not a great idea. If I was doing this again, I would make sure that the slicers that I'm using for the eyes and the slicers for the servo points are different. Hey ho. So for reference, a Pico can drive 16 PWM channels, brilliant, but it only has 8 slicers, which means that there is only truly 8 unique configurations. We've got some mechanicals in terms of our model. Whereas in the Halloween one, I had a really nice light Guy Fawkes mask. This time I've gone with a full latex mask, but actually that's quite a lot heavier and it actually needs quite a lot more infrastructure. Now that's a little bit of a problem because I'm just putting these on MG996 servos, which are not really as rated to handle the sort of weights I'm talking about. I'm going to handle that a little bit by just restricting the amount of angles that the head can go through. So generally it's in a balanced position and it's not needing too much force to move it. I'm using a fairly standard off-the-shelf, or in fact a standard off-the-shelf pan and tilt kit to just attach those two MG996 servos to and then drive those. How are we actually going to attach this latex head? Well, I'm going to first of all build a little adapter 3D printed to actually hold everything up, and it's basically just going to hold a pipe, and I'm using a 2 centimeter pipe that actually everything is going to be off. So this adapter bolts nicely onto my pan and tilt unit, and it's got that a hole in the top there for our pipe to go in. And then I can create at the top of that a nice little hat, which is what the actual mask is going to sit on, or at least the top of it's going to sit on. Then I can actually have my eyes coming out of that, and they're just going to clamp onto the pipe. Nice and easy. They're going to project onto a diffuser screen, which is actually going to also push out the front of the mask a bit and make it look a little bit more realistic and not just flop it down too much. So that's going there. And then of course we need a unit for my Raspberry Pi camera and where that's going to sit. And I'm going to sit that just underneath the chin. The final thing I'm going to do is I'm going to put some stabilizers on so that I can stop the head actually flopping all the way forward or backwards. So the pitch angles will actually be quite restricted on the unit, and I'm doing that by just building a little bit of a stabilizer and then putting some PCB offsets in there to just give me that balance point and stop the head moving too far backwards or forwards. As always, all the code is on GitHub to share. So what's the design look like for this? Well, we've of course got two parts for this, the Pico and the Raspberry Pi. On the Pico, we're running Micro ROS and FreeRTOS as frameworks. So Micro ROS connects to the ROS robot operating system ecosystem, and FreeRTOS to enable me to multitask on the Pico. Now I've got a number of videos talking about Micro ROS and taking you through the journey there. Go and look at those. They're going to a bit more detail than I will talk about for Micro ROS today. They go up to a turntable, which is a really simple robot, which demonstrates some of the principles and some of the messages, the pose message we're going to use in a second. And of course DDD, my DIY dev droid, which I've driven around on this channel before. So our servos are going to be controlled with a pose stamped message. And pose stamped messages basically give the instruction to our head to rotate to a particular pitch and yaw. And the way that I'm doing that is to use the positional quaternion to orient the head. Now I'm cheating a little and using the timestamp in a way that I'm going to send a future timestamp, meaning that I want the robot to achieve this pose by a future time. And that's the way that actually I instruct it to rotate at different speeds, by actually just adjusting what is the timestamp for when I actually want this pose to take effect. The eye color is controlled by the Do Eyes topic, and that's a color RGBA message, and that's just got 4 floats in it, and I'm only using the first 3, RG and B, and there are values between 0 and 1. 1 is full on for that LED colour, 0 is full off. So on the Raspberry Pi, I'm running the Micro ROS bridge server to actually connect that into the ROS ecosystem, and then I'm going to run my facial detection or other utilities to just change the colour of the eyes or move the head around. Let's have a demo of changing the colour of the eyes and moving the head. So I'm using the ROS topics pub command to publish the Do Eyes message, and I've set it for the eyes to go green, and we can see just about there that the eyes are green. If we now change it, so we are going to set the eyes to go nicely red, and there we go, we get some nice red-eyed Santa. Of course we can go white and turn all of the LEDs of the RGB LEDs on, and we get a nice glowy white eyes. And similarly we can turn them all off as well, and let Santa go to sleep, because he needs some rest before Christmas Eve, doesn't he? So using the pose message, and I've got a bit of Python to set this, I'm going to make Santa rotate first one way to his left, and then rotate to his right, and then we give a yaw of 0 and he will rotate back to the middle. And of course we can do the same with pitch. So if I adjust the pitch 2.1, he will nod forward. I put that pitch back 2.4, he will lean his head right back, and then we can just bring his head back forward a bit. In this video I'm going to show the facial detection. You can see that the eyes go green as I'm detected, and you can see both the wide shot of the head turning around and following me, and some really dodgy hand camera work there trying to give you a sort of eye's perspective of what I'm saying. I'm not quite sure that the robot Santa portrays the jolly spirit of Santa I remember from my childhood. The most common feedback I get from those I've shown this to is it's creepy. Perhaps I should have chosen to do a Krampus mask instead. Anyway, next time I'll look at the Micro ROS approach to controlling the head on the Raspberry Pi Pico. This is very similar to the other projects I've already shared on this channel. I'll also take a look at OpenCV for facial detection. Thank you very much for watching. Please like the video as it helps other people find it. Please subscribe and hit that notification button so you don't miss the next video. Goodbye for now.